Find the indicated one-sided limit. If the limiting value is infinite, indicate it whether it's plus or minus infinity. The limit as x approaches 2 from the left of 4 minus 2x. Well, no matter what you do, plug it in, get a number, you're done. Doesn't matter what's from the left or from the right. So let's see, this becomes a square root of 4 minus 2 times 2, which is the square root of 4 minus 4, which is 0. So this limit's going to be 0. Now, what does this guy actually look like? What he actually looks like is this. He is the square root, which is flipped around the x-axis, because now we're getting into transformations, and shifted to the right by 2. That's what he looks like. The reason why they have to come in from the left is because you cannot come in from the right. And that's the domain issue. And that says that 4 minus 2x must be greater than or equal to 0, minus 2x must be greater than or equal to minus 4, or x must be less than or equal to 2. So there is nothing to the right of 2. It's a domain issue. That's when you have to use left and right hand limits. That's one of the things they said is what you're going to have to check is domain. And the problem is at 2. There's nothing to the right of 2. So the only thing you can do is take the limit as x approaches 2 from the left, because there's nothing from the right. So that's a domain one. Now this one is, if I plug in 2, this becomes 2 squared plus 4 over 2 minus 2, which is 8 over 0. What's 8 divided by 0? Undefined. What do I have? What this says is I have a 0 in the denominator, that x can't be 2. What do I have? Graphically, what do I have? Not a whole. Have to be an asymptote. This is a vertical asymptote. Vertical asymptotes are caused by division by 0. You can say, well, holes are caused by division by 0. But holes are 0 divided by 0. That's what creates the hole. It's a 0 over 0 form. That's what creates the hole. But when you've got a number divided by 0, it's a vertical asymptote. And that's why you got to think about left and right hand limits. Well, why? I can have a VA where they both go up like that. I could also have a VA where one goes down and one goes up. So they could either go in the same direction or in opposite directions. You don't know when you've got a VA. So what do? I now know I have a VA. So I need to find out if it's a VA, I'm either going to plus infinity or minus infinity. This is what VA does. It's either plus or minus infinity. Question is, I don't know which. I need to choose a number smaller than 2. Because what I'm dealing with is 2 from the left. A number smaller than 2, like x equal 1.9. 1.9, is that smaller than 2? But close to 2. So now I'm going to find out, am I dealing with positive or negative infinity? Well, 1.9 squared plus 4 over 1.9 minus 2. The denominator is negative 0.1. And the numerator is 7.61. Positive or negative? Negative. What that says now is that the limit as x goes to 2 from the left of x squared plus 4 over x minus 2 goes to negative infinity. It says it's going down on that side. And it says why? Because what I'm dealing with is a negative number. I'm dealing with a negative number. See, once I establish this plus or minus infinity, I just need to know, is it plus infinity or is it minus infinity? If it's negative, it's minus infinity. If it's positive, it is plus infinity. See, if I pick a number bigger than 2, like 2.1, 2.1 minus 2 is a positive 0.1. That means the other side's going up. So one side's going down, the other side's going up. So I have a situation similar to this with a VA. That's going to be important to us as we get into the world of graphing. Sorry. That's chapter 3. Lots and lots and lots of graphs. Well, first thing I always do, plug it in. 1 minus the square root of x over 1 minus 1. Now what do I have? 1 minus the square root of 1. What do I have?
0.
And what does 0 to 0 mean? A hole. I have a hole in the graph. If it's a hole in the graph, that means if I come in from the left and I come in from the right, I'm coming in on the hole. It doesn't matter what side I come in on. There's a hole.
It's also called an indeterminate form, correct?
It's called an indeterminate form, yeah.
Which you need algebra to solve.
Yeah, that's a good thing. What does it scream? Algebra. Algebra, 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 algebra. It screams algebra. And what form of algebra am I going to have to use on this sucker? It's got a radical, so what do I have to use? The conjugate. And since the radical's in the numerator, I'm going to rationalize the numerator. So x times x is x squared. Inner outers add the 0. Last is minus. Square root of x times square root of x is just x. And then I leave the denominator alone. Now what do I do? Factor out an x in the numerator. There's x minus 1. That's the sucker it's going to go. So x minus 1's go. This is x over x plus the square root of x. And that's what I'm going to take the limit of. So, take the limit as x goes to 1 from the left of x over x plus the square root of x. Now, I don't have an issue when I plug in 1, do I? Is there an issue when I plug in 1? Nah. So I can just plug it in and plug it in. So 1 over 1 plus the square root of 1 is 1 over 2 or 1/2. So limit's 1/2. But I have a whole. That's the y value at the whole. So if x equals 1, y equals 1/2, that would be the value at the whole.